Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. Please note that, guys, on this video I will start tackling past exam question papers concerning inorganic chemistry. Please expect 33 videos because organic chemistry is a big chapter, guys. It carries 15 plus minus 50 marks. That's a third of paper 2 only altogether. So if you master organic chemistry, it will be much more easier for you to pass your physical science. Okay, how to approach questions like this, guys? Please note that if you are given a structural formula, your duty is to write down the IUPAC name, and if you are given the IUPAC name, you must draw a structural formula. And also, if you are given a condensed structure, you must draw a structural formula and write the IUPAC name. So before I even start answering the questions, I will go and analyze each and every compound I have there. Ne? Okay, compound A. I can see that I only have carbon and hydrogen atoms only. So I'm dealing with a hydrocarbon that has single bonds between adjacent carbons. So I'm dealing with an alkane. So whenever I'm naming an alkane, I just need to start counting from the terminal carbon that is closer to the side chain rather. Are you together? So my longest chain will start from here. It will go like start from here. It will go like this. Are you together? Such that my longest chain will have one, two. Let me write the numbers. My longest chain will have 1, 2, 3, 4, 5, 6 carbons. Are you together? So since my longest chain has 6 carbons, I'm expecting not that I'm expecting, the prefix of the IUPAC name should be hex. Okay, so now let me name this hydrocarbon. I can see that in carbon number 2 there is a side chain, and also in carbon number 4 I have the same side chain. So whenever I name this organic compound, I'll simply say this is 2.4. It's dimethyl hexane. The di, guys, simply means I have two of the same things over there, ne? And please note that every time whenever you write down your IUPAC name, numbers and letters need to be separated by a hyphen like this. Are you together? Numbers should not be next to letters. They should always be separated by a hyphen. Okay, now let's go to compound B. Compound B has a hydroxide ion. Are you together? Or hydroxyl group. That means I'm dealing with an alcohol. Are you together? And this type of an alcohol is a primary alcohol. Why is it a primary alcohol? Because the carbon which is bonded to the hydroxide ion is at the terminal end. Are you together? So whenever I name this compound, since I have 3 carbons on my longest chain, I'll simply say this is propane. And then I need to state where is my functional group. My functional group is in carbon number 1. So this will be propane 1-ol. Okay, and then now let's go to compound C. Compound C, we are given a molecular formula, and this type of a molecular formula is for ketones and aldehydes. Are you together? And ketones and aldehydes are isomers of one another. So the examiner will tell us whether we are dealing with a ketone or we are dealing with an aldehyde. So for compound C, if ever we are dealing with a ketone, our structural formula will be like this. We'll have a double bond O there, and then you'll have your hydrogens. Are you together? If the compound was an aldehyde, you'll have your double bond O on the terminal carbon. You'll write your H's there. No? If you can see these two compounds, they have the same molecular formula, because if you count the number of carbons, you'll find 4 carbons and 8 hydrogens with 1 oxygen. These two these two compounds are isomers of each other. Are you together? Remember that isomers, they have the same molecular formula and different structural formula. Excuse me. Okay, now let's go to compound D. Compound D, let me draw it like this. I have CH3, that means I must have 3 hydrogens on my first carbon. And then I have CH2, which should appear 4 times on my compound, because the CH2 should appear 4 times. Are we together? So I'll simply have H is there. Each carbon has 2 hydrogens, and that should appear 4 times. Okay, and then now let me focus on the others. I have a CH, C and 1 hydrogen, as well as C with 2 hydrogens. If you can check, guys, the last 2 carbons, they are not fully bonded, because carbons should have, each and every carbon should be surrounded by 4 bonds. Are you together? So since they are not fully bonded, it simply means that there is an extra bond between the adjacent carbons. Are you together? Such that whenever I name this thing, I will start counting from the carbon which is closer to the double bond. So this will be carbon number 1, carbon number 2, 3, 4, 5, and 6, 7. Eh? So when the longest chain has 7 carbons, please note that my prefix will be hept, and then my double bond is between carbon number 1 and carbon number 2. I will always pick a similar number between the 2 carbons, so I'll say hept 1 in. Okay, then compound E has unknowns, so we don't know what compound E. We don't know the molecular formula of compound E. We'll probably find it as we continue. Now let's start answering the questions. Okay, define the term unsaturated hydrocarbons. Unsaturated hydrocarbons are organic compounds that consist of hydrogen and carbon only, and they have and there are more than 1 bonds between adjacent carbons. For example, compound D is an unsaturated hydrocarbon because it has a double bond between the adjacent carbons. Okay, and then 2.2.1, they want us to write down the letter that represents an unsaturated hydrocarbon. Unsaturated hydrocarbon, we just said it's D. Why? Because it has a double bond between adjacent carbons. Okay, and then compound A, they want us to write the IUPAC name of compound A. We already did that. We said this will be 2.4 dimethyl hexane. Okay, the IUPAC name of the positional isomer of B. For positional isomer, guys, you just need to take your functional group and place it on a different carbon. So the positional isomer will look like this. 1, 2, 3. Yes, you will have your hydrogens, but now the only difference is that now you will place your functional grouping on the different carbon. Are you together? So the IUPAC name of the positional isomer, yes, the prefix is still the same, propan 2-ol, because now the hydroxide ion is in carbon number 2. Then 2.2.4, they want us to write the IUPAC name of compound D. We already did that. We said this will be hept 1 in. And then 2.2.5, balanced equation using molecular formula for the complete combustion of compound A. What is compound A? Compound A is our alkane over there. Ne? How many carbons do we have? We have 6 on our parent chain, and then we have 2 carbons from the side chains. Ne? So our complete combustion, guys, should be like this. Since we have 8 carbons, we should have 18 hydrogens, right? Complete combustion it's when you are reacting a hydrocarbon with an oxygen. So for complete combustion, you must have carbon dioxide and water. All you need to do, guys, is to balance the equation. Okay, how many carbons are there on the left hand side? We got 8. On the right hand side we have 1. So if I just place an 8 there, I know that 8 multiplied by 1 will give me 8. So the carbons are even in both sides. And then the number of hydrogens, I have 18, and on the right hand side I only have 2. So I just have to put a 9 there out together. And then now all I need to do is to balance the number of oxygens. How many oxygens do I have? 8 multiplied by 2, that will be 16. And then 9 times 1, that will be 9. So in total, I'll have 25 carbons on my right hand side. So the coefficient here, the stoichiometric coefficient of oxygen, should always be a half of this number. Alright, together. So since a half of 25 will give us a fraction, we will simply write 25 all over 2. For us to remove that denominator over there, just multiply each and every stoichiometric coefficient by 2. So I'll simply say 2C8 H18. Whenever I multiply this by 2, I'll simply get 25 oxygens. When I multiply this by 2, I'll simply get 16 carbon dioxide. When I multiply that by 2, I'll get 18 H2O. Now let me check whether my reaction is balanced. I have 16 carbons, 18 hydrogens, not 18 rather, 2 times 18, that's 36. I also have 36 over there. And then I have 50 oxygens. I have 32 plus 18, which is 50. So now everything is balanced. Whenever they mark you guys for the complete combustion, they will mark you for writing the correct products, which is carbon dioxide and water. And then the third mark would be for balancing. So even if you're struggling to balance, at least you will get 2 marks for writing carbon dioxide and water. But obviously, guys, I always preach that you should go for full marks. Please learn how to balance. If you're struggling how to balance these equations, just click on the link. Just click the link rather on the description below. It will direct you to the videos whereby I teach organic chemistry from scratch. Okay, so the balanced equation is just 2C8H18 plus 25 oxygens, which will give us 16 CO2 plus 18 H2O. So that's our balanced equation, right? Okay, the formula C4H8 represents 2 compounds that are functional isomers of each other. Remember that we did say that compound C can be a ketone or an aldehyde. Okay, define the term functional isomer. Functional isomers are 2 organic compounds that have the same molecular formula but different functional group and also different structural formula. That's a functional isomer. And then 2.3.2, write down the structural formula of each of these structural isomers. These are the structural formulas, guys, with the H's all around. Just write an H there. If they would ask you for IUPAC names, you'd simply say for the ketone is butane, 2-one, and then for the aldehyde is just butanol. Okay, and then 2.4, we are told that a sample of A sample of compound E contains 1.09 grams of carbon and 0.8 grams of hydrogen. The molecular mass of compound E is 88. We are supposed to determine the molecular mass, rather the molecular formula of compound E by means of calculations. Okay, we can get the molecular formula of compound E by using by the use of empirical formula. Empirical formula, guys, yes, is taught in grade 11, but not actually in grade 10, but it is applicable, guys, even here in grade 12. Okay, we are told that the total set, we have C, let me see the compound, is CXHYOZ. CXHYOZ. This thing has a sample of 2 grams altogether. We are trying to find the molecular formula of OZ. So for us to determine the molecular formula, we must basically find the value of Y, the value of X, and the value of Z. How can we do so? By means of using empirical formula. We are given a carbon, hydrogen, and oxygen, and then we are given their masses in grams. We are told that our carbon has 1.08. Let me confirm. The carbon is 1.09, and the hydrogen is 0.18. Okay, that's 1.09. Hydrogen is 0.18. So how can I find the mass of the oxygen? I'll simply say 2 minus 1.09 plus 0.18. 2 minus the sum of 1.09 plus 0.18. This will give me 0.73. Remember that, guys, I did that because whenever I add all these masses, I must get 2 grams altogether. So 1.09 plus 0.18 and 0.73 should all give me 2 grams, like that. Okay, now all I have to do is to find the number of moles of each of the compound there. Remember that, guys, number of moles is always mass all over the relative atomic mass number altogether. So for carbon, the mass number is 12. Let me write like this. The atomic mass number is 12 grams per mole. And then the relative atomic mass number for hydrogen, I have 1 grams per mole. And then the relative atomic mass number for oxygen is 16 grams per mole. So whenever I want to find the number of moles, all I have to do is to say the mass, which is 1.09 divided by 12. 1.09 divided by 12. This will give me 0.09. Okay, and then when I say 0.18 divided by 1, I'll simply get 0.18. And then I'll say 0.73 divided by the molar mass, that's 16 grams. 0.73 divided by 16, I'll simply get 0.045. 0.45, ne? Okay, after doing this, guys, I must then go and check which one has the smallest number of moles. I can see that my oxygen has the smallest number of moles. So for me to be able to find the the subscripts over there. For my empirical formula, I just need to find the ratio. All right, together, I'll just take I'll just divide each and every number of moles by the smallest number of moles over there. 0.045, 0.045. So I had 0.09 for carbon, 0.18, and then I had 0.045. And whenever I write down my ratios, guys, I must always round off to the nearest whole number. So 0.09 divided by 0.045, this will give me 2. And then 0.18 divided by 0.045, this will give me 4, and then that one will give me 1. So therefore my empirical formula will be C2. This will be the subscript for carbon, like this, will be C2H4 with an O. Out together. So this is my empirical formula, guys, but I was never asked to find empirical formula. I was asked to find the molecular formula, right? And I was told that the molecular mass, the atomic mass number for my molecule is just 88 grams per mole. Out together. If I'm given this thing over here, out together, I must then compare. I must then find the molecular mass number of my empirical formula and compare it to the one that I'm given. If they are the same, therefore my empirical formula is the molecular formula. Right, together. Okay, let me go and find the relative atomic mass number of the empirical formula. How many carbons do I have? I have 2. And the mass number for carbon is just 12. How many hydrogens do I have? I have 4. The atomic mass number is 1. And then I have 16. This will give me 44 grams per mole. The empirical formula has the relative atomic mass number of 44 grams per mole, but the molecular formula has 88 grams per mole. So what I need to do is to find the ratio of the two. I'll just say the molar mass of the empirical formula divided by that of the molecular formula. No, man, excuse me, guys, it's vice versa. The empirical mass of the molecular formula divided by that of the empirical formula. I'll simply get 2. After finding these 2, I will just multiply my subscript by the 2 for me to be able to get my molecular formula. So this will be C, H, and O. My subscripts will be 2 multiplied by that 2 over there. I'll get a 4. And then I'll say 4 multiplied by that 2. I'll get an 8. There's a 1 over there. 1 multiplied by 2, I'll get a 2. So this would be the molecular formula. Are you together? So the molecular formula is just C4H8O2. That's how, guys, we're supposed to deal with this question. I know that we dragged the empirical formula, but if you're struggling with empirical formula, guys, please check my videos whereby I teach stoichiometry. I do have videos in empirical formula. Just stay tuned and wait for more. Thank you.